This lesson is part of a series of training videos where we will look at a specific product and a specific installation, comparing our installation instructions and good practice with actual conditions on a job site. The primary goal is to help you become more familiar with our products, enabling you to tell if they have been installed correctly and if they're doing what they're supposed to be doing. Along the way, we'll also discuss what's important for when we need to determine if something is close enough, what's dangerous for when we need to bring something to the contractor's immediate attention, and why our products are used the way they're used. These videos will assume you're already somewhat familiar with the products being discussed. If you haven't already done so, please take some time to watch our other product training videos that go into detail on our various products, features, and components. Vibro-Acoustics creates noise control solutions for the HVAC industry, addressing both airborne and structure-borne transmission paths. Our vibration isolation products help mitigate equipment vibrations that could cause noise problems in buildings. In this lesson, we will look at flexible elastomeric pipe connectors or expansion joints used for hydronic pumps and water-cooled chillers on vibration isolators. We'll also look at expansion joint flexible connectors used within an isolated cooling tower. In late 2016, Vibro-Acoustics secured a vibration isolation order for a project in downtown Toronto called Daniels Waterfront South, a mixed-use condo and office building. The mechanical penthouse of the East Tower includes various pieces of equipment, including base-mounted pumps. The condenser water pumps are located in this area here. Here's a picture of the condenser water pumps. As required by the project documents, the pumps are supported by concrete inertia bases on open floor springs and have flexible connectors on both the suction and discharge piping. We'll go ahead and walk around the installation, focusing on the flexible connectors, and then look at the data sheets and installation instructions. After that, we'll take a closer look at the double sphere expansion joint flexible connector on the suction pipe and discuss what we should be looking for during a site visit. This is the suction pipe bringing water from the cooling tower. It is supported with vibration isolators and includes a double sphere neoprene flanged expansion joint or flex connector. The two end suction base mounted pumps each have their own flexible braided metal connector on the discharge side, which we discuss in a separate training video. The pumps are secured to concrete inertia bases supported by 2-inch deflection floor springs, which are also discussed in a separate training video. We'll pause here and take a look now at the data sheet and installation instructions for these flanged expansion joints. Flanged expansion joints are used as flexible connectors in piping and come in two primary configurations, single sphere and double sphere, and two primary materials, EPDM and neoprene, though other elastomers are available. In addition, these two data sheets also show the common accessory known as control rods. The expansion joint we just looked at is a double sphere neoprene type, and since it didn't have the control rods, we'll hide those for now and discuss them later. The data sheets include information useful in determining dimensional requirements and limitations, as well as maximum system pressures and temperatures where these products can be used. The model names are shown on the left, followed by the corresponding material. You'll note that the third letter in the model name corresponds with the first letter in the material name. Then the size or diameter of pipe for that model, followed by the operating face-to-face length of the flanges. We'll show this shortly. The next section of columns indicates the maximum amount of movement in the various directions that each model can accommodate: lateral or side-to-side, axial extension and compression, and then angular, where the axis of one end is not in line with the axis of the other end. Note as well that the joint cannot accommodate these maximum deflections simultaneously. These columns highlight the functional differences from flexible metal hose connectors, which cannot allow angular or compression or extension movement. The next columns show us the maximum working pressure with and without control rods, which are used to achieve higher pressure ratings or where needed to prevent excessive movement. And the last column shows the maximum temperature of fluid flowing through the joint. These temperatures are above what is commonly found in HVAC systems. Note that EPDM is suitable for slightly higher temperatures than neoprene. It is also more suitable for use outdoors where exposed to ultraviolet rays. The expansion joint we just looked at was an 8-inch diameter neoprene model, so we'll want to keep in mind the various dimensions and operating limitations listed here during our review. Moving over to the installation instructions now, we'll focus on things we can check during a site visit. We have separate installation instructions for with and without control rods, so since this joint did not have them, we'll look at those instructions. First, make sure it's the right expansion joint in the right place. Check joint material, fluid pressure, and temperature. As long as the piping system is serving typical HVAC systems, you usually don't have to worry too much about pressure and temperature. Next, while these expansion joints can accommodate offsets, they should not be used to correct misalignments. We'll want to make sure the connected pipes are aligned within about 1/8 of an inch. It's important that the expansion joint not bear too much stress. The pipe system should be anchored nearby to control pressure thrust caused by pump startup or shutdown. Control rods should be used if the pipe isn't anchored. Elastomeric expansion joints should not support dead loads or pipe weight. They need to be supported on either side to allow them to provide flexibility. This is a common one that is overlooked. The bolt heads should be placed against the expansion joint flanges so that they stick out away from the center of the joint. The nuts should be on the pipe flange side. I'll explain more when we get to the pictures. The connectors are made slightly longer to help with sealing against the adjacent pipe flanges. It can be a tight fit to get them in place, but once in place, the face-to-face dimension from flange to flange should match the value shown on the datasheet chart. Really important is to make sure the expansion joint is connected directly to ANSI standard bolt flanges immediately adjacent to the joint. There cannot be another component that doesn't have a bolt flange, such as a wafer-type check valve or a butterfly valve, between the expansion joint and the pipe flange to prevent damage to the joint and ensure a proper seal. Since the joint is made of a compressible material, the installation requires a few steps of tightening the flange bolts to ensure a proper seal on either end. The bolt torque table here gives appropriate values for torque and minimum wait times before proceeding to the next round of tightening. Tightening should be done in a star pattern or alternating around the ring. Final torque values need to be within the range shown here. For the joint we just looked at, the torque values for all bolts should be between 60 and 75 foot-pounds as measured using a torque wrench. Note that the bolts should never be tightened to the point where the expansion joint flange and the pipe flange touch each other. There is a cautionary note below the table that warns of premature failure if the bolts are over-torqued. The flange bolts should be checked periodically to ensure they remain in the torque range, so regardless of when the site inspection occurs, the flange bolts should always be in that range. So now we're ready to go through the checklist and see how good is this installation of a twin sphere expansion joint. First, is the right expansion joint in the right place? The material is neoprene, which is appropriate for indoor applications. The pressure will be fairly low since this is just before the inlet to the pumps and there isn't a large column of water on the other side of the wall, so it's definitely below the 134 psi safe working pressure limit. And the temperature will certainly be below 230 degrees Fahrenheit since this is just water returning from a cooling tower. So this one is okay. Second, is the misalignment less than 1/8 of an inch? Based on lining up the flanges on either side and considering the center lines of the pipes on either side, it certainly appears to be collinear. No discernible offset, so this is okay. Third, are control rods not needed? The pipe appears to be solidly connected to the pumps on one side and it goes through a wall on the other side, so there appears to be very little opportunity for the pipe to move much. There doesn't appear to be any reason to add control rods here, so it's okay as is. Fourth, is the expansion joint properly supported? There are clevis hangers on either side of the joint, very close to the flange connections, so there is no weight other than its own being supported by its connections to the flanges. This is definitely okay. Fifth, are the flange bolt heads up against the connector flange? Well, no they aren't. I'm not sure why contractors often install them this way, but it presents a higher risk for damage to the body of the expansion joint since typically the bolt head is held in place while the nut is turned with a wrench. A slip while tightening a nut could result in the sharp edge of a wrench going into the side of the joint. Further, if the flange bolts are very long, they could run into the side of the joint during system operation movements and cause damage to the body of the joint. In this case, there was no noticeable damage and the bolts were not long enough to touch the joint body, so this one is close enough. No need to get the contractor to reinstall these. Is the face-to-face dimension correct? The distance between the flanges is about 13 inches, as stated on the datasheet. The expansion joint isn't stretched or compressed, so it's okay. Is the expansion joint attached directly to the pipe flanges without any other unflanged component in between? As we can see here, the joint flange is connected directly to the pipe flange, so this is okay. Eighth, are the bolts tight enough? I didn't bring a torque wrench to check, but in some cases it may be appropriate to spot check the flange bolts to ensure the contractor has followed the multi-step process to get the bolts in the correct torque range. These appear to be okay. And finally, are the flanges not touching each other? Nope, there's definitely an appropriate gap between the flanges where you can see the expansion joint bead and the flange bolts. This is okay. So overall, not a perfect score with the flange bolts installed backwards, but close enough to call it okay. We're going to go to another project now to look at some installations on other equipment and where control rods were used. This project was done in 2015 and is called the Axiom Condominiums, which is also located in downtown Toronto. Here shown on the East Tower mechanical penthouse floor plan is a water-cooled chiller and its associated cooling tower. We're going to go look at both of these pieces of equipment and focus on the expansion joint flexible connectors complete with control rods used on their pipe connections. As we did with the pumps, we're going to play a short walk-around video, first of the chiller, and then go through the installation instructions for expansion joint control rods. Then we'll take a closer look at one of the joints and go through the inspection questions. After that, we'll finish up with a quick look at the cooling tower and its expansion joints. Starting on the far side of the chiller, we'll walk past the condenser shell and note that the chiller is mounted on springs and any pipes attached have some kind of flexible component to limit the transmission of vibration to the structure. As typical, the condenser water pipes are not insulated, allowing us the opportunity to see the single-sphere neoprene expansion joint flexible connectors complete with control rods. Here, I'm confirming that the rods are loose, which is important to minimize vibration transmission. Walking around to the second expansion joint, everything seems to be in good shape here as well. When I tried to move the control rod, however, I found it to be tight, meaning that either the expansion joint has extended to its maximum length, or more likely that the nuts were just set too tight. This isn't dangerous, but it could allow chiller vibrations to bypass the joint and find their way into the building and create noise. Here are the installation instructions again. We're going to go look at the second page now, which describes how to install an expansion joint with control rods. The expansion joint must be installed between the pipe flanges first, as we previously described. Next, the control rod plates need to be attached, equally spaced around the flanges, with bolts that pass through the plate and both the pipe flange and the joint's floating flange. Next, the control rods need to be inserted through the corresponding holes in the plates, complete with steel washers, rubber washers, and nuts. Typically, control rods are made using threaded rods cut to length with a nut fixed at one end with weld or Loctite. At the other end, typically two nuts are used, tightened against each other to keep them positioned so that the joint does not exceed its maximum allowed extension, as we saw in the datasheet. Where joints will see compression, additional pieces of pipe can be added to the control rods, cut to length to ensure the joints do not exceed the maximum amount of compression as listed on the datasheet. So let's take a look at these joints and their control rods. We'll go through the same questions we asked earlier. Is this the right expansion joint in the right place? These are neoprene joints, and as with the previous example, since this is condenser water and it's not going to be at a temperature or pressure that exceeds the joint limits, these are okay. Is the misalignment no more than 1/8 of an inch? The pipes appear to be adequately aligned. I noticed that the upper flange and lower flange appear to be slightly rotated relative to each other, but it wasn't excessive since the control rods were still able to line up okay through the holes in the control rod plates. So this is okay. Are the control rods installed okay? This question is a little different from before when we were making sure they weren't needed, so here that they have been installed, we'll consider a couple extra questions. Are the rods straight, even, and loose? They do appear straight and aligned with the center line of the pipe. The two rods are evenly distributed around the pipe, being on opposite sides from each other, and they are loose on one of the two pipes but tight on the other, as we saw in the video. So this one is a maybe. It would be good to try to loosen up the control rods, but if there aren't any noise problems, it could be left as is. Are the rubber washers and jam nuts installed okay? The rubber washers, which are needed to minimize any vibration transmission through the rods since they can act as short circuit paths even when loose, are installed, and the jam nuts needed to prevent excessive movement are also installed, though perhaps a little too close on the one joint, but they're there, so this point is okay. Overall, question number 3 is mostly okay, but as mentioned, if there is a noise problem, the control rods should be loosened. Is the expansion joint properly supported? In this case, the short length pipe below the joint is supported by its connection with the chiller, and the pipe above is supported by hanger rods to the structure above. It is best to minimize the amount of pipe between the chiller and the joint since the chiller connections are not designed to take much load. Since the control rods are loose on the one joint, that one is definitely okay. The joint isn't supporting more weight than its own. I would guess that even though the rods are not loose on the second joint, it's probably okay as well since there is very little pipe between it and the chiller connection. So we'll call this okay. Are the bolt heads against the connector flange? Nope, just as before, the bolts are backwards. But also as before, I found no damage to the bodies of the joints, so there's no need to ask the contractor to fix this. We'll call this one close enough. Is the face-to-face dimension correct? I didn't measure these, but probably should have at least measured the second one. Neither one looked excessively stretched or squished, so I think I'll call these close enough, and okay as well. Is the joint attached directly to the pipe flanges? Yes, in both cases. They got that right, so that's okay. Are the bolts tight enough? Again, I didn't check these with a torque wrench, but loose bolts can allow leaks, and there was no evidence of that, so I would call this close enough and okay as is. Are the flanges not touching? Nope, the flange bolts have not been over-tightened, and there are gaps between all pipe and joint flanges, so that's okay. We're going to wrap this up with a quick walk around and close-up of the expansion joints on the cooling tower that's located just next to the chiller. Here are the condenser water pipes connecting the cooling tower to the chiller and pumps. The condenser water is pumped from the chiller room up and into the top of the tower, where you can just see an expansion joint at the top. The water falls through the tower while fans pull air across the water, cooling it down. The lower pipe brings water from the tower basin back to the pumps. The expansion joint at this connection uses EPDM material since it is outside and amazingly has the bolt heads in the right places. The control rods are loose. Out of all the joints we have seen, this one is just about perfect. If you were to go through the various questions, you would find that everything is okay. The expansion joint at the top of the tower is pretty good. My concerns on this one were the bolts being backwards again, the control rods not being loose, and there being a possibility of the joint helping to hold up some of the pipe on one side or the other. But nothing dangerous and nothing that I would say needs to be fixed or adjusted unless there were a noise problem. So I was willing to call it close enough and maybe okay. So that's a look at 5 expansion joints on 3 pieces of equipment with and without control rods. We've covered the datasheets and installation instructions for the most common configurations and gone over the 9 or so questions to consider when performing a site inspection for these products. They are key components to incorporate in HVAC systems to control vibration and prevent noise in buildings. I hope through this lesson you've become more familiar with elastomeric expansion joints and their use.